Hello everyone, welcome to my channel. In this video also we solve we continue the partial differential equations. So in this section we study the linear partial differential equation of first order. So any partial differential equation of the first order is called linear if it is of the first degree in P and Q. That is, the degree of the P and Q is 1, then it is called the linear partial differential equation. Next, Lagrange's linear equation. The linear partial differential equation of the form P into P plus Q into Q equals to R, where P, Q and R are the functions of x, y, z, is called Lagrange's linear equation. So any equation of this form, that is P into P plus Q into Q equals to R, where P and Q are the first degree, therefore it is called as the linear PDE. So any linear PDE of this form is called as the Lagrange's linear equation. So in this Lagrange's linear equation, we write the auxiliary equation, that is the Lagrange's auxiliary equations are nothing but these are the equations of the form dx divided by p equals to dy divided by q equals to dz divided by r. So of the Lagrange's linear equation are called the auxiliary equations. So these auxiliary equations are very helpful while solving the Lagrange's linear equation. So the steps to, that is the working rule to solve the Lagrange's linear equations are: first step, we have to write the auxiliary equation. So auxiliary equation. So second step, we solve this auxiliary equation. So these are nothing but similar to the simultaneous equation, that is solving the simultaneous equation. So by using the method of solving simultaneous equation, we solve this auxiliary equation to get two independent solutions. That is, we may consider it as u of x comma y comma z equals to c1 and v of x comma y comma z equals to c2. Already you know about how to solve the simultaneous equation, whose link is given in the I button. Okay. Next, third one, that is in the third step, we write the solution of the Lagrange's equation as phi of u comma v is equals to 0, or you may represent it of f of u comma v equals to 0. This is the solution of the Lagrange's linear equation. Now we shall solve some problems on this section, that is Lagrange's linear differential equation solution. So first question is, solve p tan x plus q tan y equals to tan z. So now it is of the form p into p plus q into q equals to z, equals to r. So this is Lagrange's linear PDE of the form p into p plus q into q equals to r. So therefore we write the auxiliary equation. So therefore the first step is we have to write the auxiliary equation. The auxiliary equation is dx divided by p equals to dy divided by q equals to dz divided by r. Here p is nothing but tan x, q is tan y and r is equals to tan z. So therefore we get dx divided by p is equals to, we have tan x, equals to dy divided by q is equals to, we have tan y, dz divided by tan z. Okay. So comparing the given equation with the standard Lagrange's linear equation, we get this one. Okay. So this is nothing but simultaneous equation. So by using the method of solving simultaneous equation, we can get the two independent solutions. So that is, you can choose the multipliers or you can use the method of grouping. Here first we consider first two terms. So consider this as equation 1. Okay. Consider first two terms consider first two fractions. Okay, so that we get dx divided by tan x dy divided by tan y, so that it can be written as 1 by tan is equals to cot x into dx, cot y into dy. Now integrating, we get cot integration is log of sin x equals to log of sin y plus log of c1. So further it can be written as log of sin x, you can take this side or keep this log of sin x as it is, log m plus n. For using log m plus n formula we get c1 into sin y. Log get cancels, we get sin x is equals to c1 into sin y. Okay, or we can write it as sin x divided by sin y is equals to c1. So this is the first set of independent solution. So next we find another set of independent solution. Okay, so next we consider second and third fraction, or you may consider first and third fractions also. So here next we consider first and, that is second and third fractions. So we get dy divided by tan y, dz divided by tan z equals to cot y dy equals to, we can write it as cot z into dz. Now integrating on both sides, we get cot y dy integration is log of sin y log of sin z plus c2, or it can be written as log of sin y log of c2 into sin z, or we may write it as sin y divided by sin z is equals to c2. So this is the another set of independent solution. Consider this as equation. So this is equation 2, this one equation 3. So therefore the solution of the given equation is phi of u value, that is first independent solution is sin x divided by sin y, comma second independent solution is sin y divided by sin z equals to 0. This is the required solution. So next question, solve bz minus cy dou z by dou x plus cx minus az dou z divided by dou y equals to ay minus bx. So this is the next one. So here also, so this is also, so dou z by dou x is nothing but it is small p, this is small q. Okay, so it is also in the form of linear differential equation, that is Lagrange's linear equation. So this is of the form, so in the exam they make you dou z by dou x or p also. Okay, dou z by dou x is nothing but p. So this is of the form p into p plus q into q equals to r. Thus the auxiliary equation is dx divided by p. So you can observe that this is dou z by dou x small p, so capital P value is bz minus cy equals to dy divided by capital Q value is cx minus az equals to dz divided by r value is ay minus bx. Consider this as equation 1. So these are the simultaneous equations. Again we can solve these by choosing multipliers or groupings. So here we can't solve this by the method of grouping. So we choose the two sets of multipliers to get two independent solutions. Okay. So first set we choose ABC as a multipliers. Okay. So first we choose A, B, C as multipliers, so that we get then each fraction is equals to, so A into dx plus B into dy plus C into dz. So we get this bz minus cy. Okay, so multiply this fraction with A, this second with B, third with C. Okay, so multiplying with A we get abz minus acy plus bcx minus baz plus c into ay minus cbx. Okay, so you can observe that denominator all the terms get cancelled, that is abz minus acy plus acy minus bcx minus bcx get cancelled, so that we get adx plus bdy plus cdz divided by 0. So therefore we can write it as adx plus bdy plus cdz divided by 0, or it is equals to, simply we write it is equals to 0. So integrating we get A taken outside, dx integration is x plus b y plus c z equals to c1. Okay, so this is first set of solution. So similarly again we choose using x, y, z as multipliers. Okay, so that we get now each fraction of the equation 1 becomes, numerator becomes x into dx plus y into dy plus z into dz. Okay, so equation 1. So here for this equation 1 we are choosing x, y, z as the multipliers. So x into dx plus y into dy plus z into dz. Next b is, it is multiplied with x, so we get x into bz minus cxy plus y into cx minus y into az plus z into ay minus z into bx. Again this denominators all terms get cancelled, so we get x dx plus y dy plus z dz divided by 0. So it implies that x dx plus y dy plus z dz equals to 0. Now on integrating we get x integration is x square divided by 2 plus y square divided by 2 plus z square divided by 2 equals to, we write it as c. Constant of integration is c, or it can be written as x square plus y square plus z square equals to 2c. It is replaced by c2. So the second set of independent solution is x square plus y square plus z square. 2c is nothing but it is a constant, so we write in terms of another constant, that is c2. So thus the solution is, the solution of given equation is phi of, you can write phi of or x f of. Okay, so phi of the first set of independent solution is ax plus by plus cz, comma second set is x square plus y square plus z square equals to 0. Okay, so this is the solution of the given equation. Next example, the most important for your exams. X square p plus y square q equals to z square. So here you can observe that here p value is capital P value is x square, q value is y square, and z value is, that is r value is this z square. So this may given as, so in the exam it may be given as x square dou z by dou x, because p value is dou z by dou x, plus y square dou z divided by dou y equals to z square. So it may be given as like this also. Solution. So this is nothing but Lagrange's linear PDE. Okay. So this is of the form capital P into small p, capital Q into small q equals to R. So thus the auxiliary equation is dx divided by p dy divided by q equals to dz divided by r. So which is nothing but dx divided by, so in the given equation p value is x square. Okay, so here p is equals to x square, so it is x square dy divided by q value is y square and dz divided by r value is z square. Okay, consider this as equation 1. Now to solve this, simply we can, without choosing the multipliers, we can solve this by using the method of grouping. Okay, so first we consider first two fractions. Consider first two fractions. Okay, so that we get dx divided by x square equals to dy divided by y square. So then we get dx by, so integrating we get dx divided by x square 1 divided by x square difference integration is, that is integrating 1 by x square integration is 1 by x equals to 1 by y plus we write, you can write here c1. Okay, so that is we get 1 by x minus 1 by y is equals to c1. This is the first set of solution. Okay, next we find another set of solution. For that you can choose this for second and third or first and third also. Okay, for the another set of solution we choose second and third fraction. So now consider second and third fraction. Okay, second and third fractions, so that we get dy divided by y square equals to dz divided by z square. So again integrating we get y square integration 1 is 1 by y is equals to 1 by z plus c2, or 1 by y minus 1 by z is equals to c2. So this is another set of independent solution. So thus the solution of given equation is phi of first set of solution is 1 by x minus 1 by y, and the second is 1 by y minus 1 by z equals to 0. Next problem, solve zp plus yq is equals to x. So this is also of the form p into p plus q into q equals to r. The auxiliary equation is dx divided by p value is z here, dy divided by y plus dz divided by x. Okay, so consider this as equation 1. So first set of independent solution can be considering by use this first fraction and second fraction. Okay, so that we get, consider first and third fraction. we get dx divided by z equals to dz divided by x. So it can be written as x into dx equals to z into dz. On integrating, we get x integration is x square divided by 2 equals to z square divided by 2 plus we write c, or it can be written as x square by 2 minus y square divided by 2 equals to c. Taking 2 as a LCM, we get x square minus y square is equals to 2c, or it can be further written as x square minus y square. This 2c is replaced by another constant c1. So this is first set of independent solution, or we may write it as, sorry, it is nothing but z. This is z value. So we write this z square as, so z square can be written as x square minus c1. Okay, so that z can be written as root of x square minus c1. So this value we use to solve the, that is to get the second independent solution. We substitute this value in the equation 1. Okay, so putting this value in equation 1. So substituting in equation 1, we get dx divided by z is equals to, we get root of x square minus c1 dy divided by y is equals to dz divided by x. Now we can observe that, so this is in terms of x, okay, dx divided by x, z is replaced in terms of x, dy by dy. To get the another set of solution, we consider these two fractions. Now consider first two fractions, so that we get dx divided by root of x square minus c1 is equals to dy divided by y. So now integrating, we get 1 by root of x square minus c1 integration is sin h inverse of x divided by c1 equals to log y plus c2. Integration constant, we choose it as c2. So that sin h inverse of x c1 minus log of y is equals to, we write c2. So this is second set of solution. Therefore the solution of given equation is phi of the first set the first independent solution is this one, x square minus z square equals to c1. So therefore we write x square minus z square, comma, the second set is sin h inverse of x divided by c1 minus log of y equals to 0. Next problem, x square dou z by dou x plus y square dou z by dou y equals to x plus y into z. Okay, so this can be written as, so in the, even in the exam also they may give as x square p plus y square q equals to x plus y into z. Okay, so solution of this one is, this is of the form p into p plus q into q equals to r form. Thus the auxiliary equation is, that is auxiliary equations are dx divided by x square equals to dy divided by y square plus equals to dz divided by x plus y into z. Okay, consider this as equation 1. Now the first set can be obtained by considering first two fractions, that is consider first two fractions. We get dx divided by x square dy divided by y square. On integrating, we write integrating, we get 1 by x equals to 1 by y plus c1, or 1 by x minus 1 by y is equals to c1. This is first set of solution. To get another set, we use the multipliers. Okay, so using 1 by x, 1 by y and minus 1 by z as multipliers, each fraction equals to, so first fraction is multiplied with 1 by x, so equation 1 is, that is first fraction is multiplied with 1 by x, so we get dx divided by x plus dy divided by y minus dz divided by z. Denominator becomes, so here denominator, this is multiplied with 1 by x, one term of x get cancels, we get x plus y minus, we get x plus y. So here plus x minus x get cancels, plus y minus y get cancelled, so that we get dx divided by x plus dy divided by y minus dz divided by z divided by 0. It implies that dx by x equals to dy by y, plus minus dz by z equals to, we get 0. Now integrating, we get 1 by x integration is log x plus log y minus log z equals to log c2. So further simplifying, we get log m plus n, formula is log m into n divided by minus log z, so divided by, we get z equals to log c2, or we get xy divided by z is equals to c2. This is another set of solution. So therefore the solution of given equation is phi of, the first set is 1 by x minus 1 by y, comma another set is xy divided by z equals to 0. So this is the required solution. So like this we can solve any Lagrange's linear equation, so by using the concept of simultaneous equation. Okay, so that is simultaneous differential equations. Okay, so next we have one more examples. You try this by yourself. xp plus yq equals to z, and its answer is f of, or you can write phi of x divided by z, y divided by z equals to 0. So it's very simple. Simply you consider auxiliary equation. So consider first two fractions, then two fractions, you will get the, that is by the method of grouping, you will get the two set of solutions. One is x by z, another one is y by z.